Good evening everyone. Welcome to the second video on the structured questions in the homework portal from the chapter on mechanics. We will be doing 3 questions as a part of homework portal so that it will help you out to do all your problems well in your final examinations. And as a result of it, I keep on putting across questions in the database in YouTube, and then every day 3 questions have been released. Today was the first day to start on the structured questions. Tomorrow, the solutions for these questions will be made available to you. And again, tomorrow, a fresh set of 3 more questions will be put across. I think tomorrow it will be there. Day after tomorrow, I may not find time to give you the solutions. Let me find out to record it and so on. So, as a result of it, I think I don't want to release it. Okay, let me release it tomorrow. But solutions, I think it will take at least a day or two for me to put it across, to record it and put it across. It takes some time for me. Okay, so without wasting my time, myself, I am Ratankar Rao. I teach physics in an international school in Bangalore. And my hobby is to make videos and see to it that it helps all my students. ठीक है, so अभी तो शुरू करेंगे हम इसके बाद. Now, अरे यार, I couldn't see my PPT. Just give me a moment. I don't know why I'm not able to see my PPT. Just give me a moment. Oops. Okay, I think I have changed some settings, and as a result of it, I'm getting something else. Anyway, let us begin with the second video. Now, let us go to second slide. So the question here states something like the diagram shows below part of a downhill ski course, which starts at point A, 50 meters above the level ground. So this height is 50 meters. Point B is 20 meters above the level ground. Okay. A skier of mass 65 kg starts from rest at point A. It starts from rest at point A. And during the ski course, some of the gravitational potential energy is transferred to the kinetic energy. Some of the, not all. Okay. Some of the potential energy is transferred to the kinetic energy. From A to B, 24% of the gravitational potential energy is transferred to kinetic energy. Show that the velocity at B is 12 meters per second. So what you need to do is, you need to first find out what is the gravitational potential energy, and you need to say that 24% of them has been transferred to as kinetic energy at point B. Okay, so you need to find out what is the kinetic energy here. So you need to find, using this information, you need to find out like what is the velocity. The velocity is seen to be 12 meters per second. I will not tell you the mathematical equation, but I can just tell you that this is something that you need to do. You need to get potential energy at the top. You need to get potential energy at the top. And you also need to get the kinetic energy here. And then somehow, with some way, you need to equate it. That's it. Okay, now let me move on to the next question. The question is quite simple. Easily you can do this. Now, some of the GP is transferred into internal energy of the skies. Okay, is slightly increasing the temperature. Distinguish between internal energy and temperature. So, what do you mean by internal energy and what do you mean by temperature? Right? Sorry, yeah, internal energy and temperature. And he says part of the gravitational potential energy is transferred to internal energy. So, you need to think as what is internal energy there, right? So, this a little bit of thinking is required. Okay, if you want, I can just tell you at this moment. Internal energy is nothing but the energy taken by the molecules of the object in doing some internal work by like raising the temperature of an object. Larger the internal energy, larger the temperature. Okay, I told you all these things. Now you need to do a little bit of research to understand or to distinguish between the internal energy and temperature. Okay, I'm not going to put it across here. So you think about it. Then the dot on the following diagram represents the sky as she passes point P. Draw and label the vertical forces acting on the sky. Okay, what is the force acting on the sky when it reaches the point P? This is the point P over here. What forces are acting? Is it the normal force, the mg force, the friction force? What has been acting? That has to be put across. Then next, the hill at point B. Let's see. Right, the hill at point B has a circular shape with a radius of 20 meters. Find whether the skier will lose contact with the ground at point B. It's slightly an off question from the first chapter. The reason is because this concept, we don't teach it here. Whenever a particle moves in a circle like this, then it will lose its contact when n becomes 0. And when it is moving in a circular path, the centripetal acceleration acts downwards towards the center of the circle. So therefore, this mv square by r acts like this. Then I have told you one of these forces, not all. Okay, and then you need to find out what other forces are acting and when will it lose contact. When I say it loses contact, the value of n should be dash. This you already know. Okay, and I already told you in the classroom also. Okay, like when will the value of n be 0? Okay, think about it and answer it appropriately. Next, the sky reaches point C with a speed of 8.2 meters per second. She stops after a distance of 24 meters at point D. Where is C and where is D? Until unless the figure is not seen, I can't get it. At this the point C here, this is the point D here. And now what does he say? He says the problem is the sky reaches point C at the speed of 8.2. She stops after a distance of 24 meters at point D. Why does she stop? Simple friction, right? If the friction was not there, definitely it will not stop. Oh my God, I told you this. Right, okay, let me determine the coefficient of dynamic friction between the base of the skies and the snow, assuming the frictional force is constant and the air resistance can be neglected. Now you know what you need to find, right? Now what kind of friction is this? Is it static or dynamic? It is a dynamic friction, right? So if it is dynamic friction, you know what equation you have to use, which means what? When the particle is moving, what kind of friction do you need to use, right? At the side of the course, flexible safety nets are used, okay? Because if suppose if the person who falls like this, okay, he crashes into it, it's better that they use safety nets. Another skier of mass 76 kgs fall normally into a safety net to speed of 9.6 meters per second. What was the first skier's weight? 55 kgs. Or second skier's weight? 76 kgs, much larger than, right? And he falls in the net with a speed of 9.6 meters per second. Calculate the impulse required from the net to stop the skier and state an appropriate unit for your answer. Impulse. What is impulse? Okay, I'm not going to tell you. You already know what is impulse. He explained with reference to change in momentum why a flexible net is less likely to harm the skier than a rigid barrier. Why do you need the skier? Why do you need the safety nets for the skier? Okay, the mass is so much, the speed is so much, it will come very abruptly, very fastly, and then come and crash onto it. Okay, so what does or how does the flexible net help him out? If you want to understand that, then learn the theory behind it and then explain it. Okay, all this comes in the concept of momentum and impulse. Okay, now this question is really a good one. He has extended like anything. Then, second question. A glider is an aircraft with no engine to be launched. A glider is uniformly accelerated from rest by a cable pulled by a motor that exerts a horizontal force on the glider throughout the launch. So what happens here? You have a glider. Now you are pulling it with the help of a cable, and as a result of it, there's a motor over here. And the moment you pull it across, immediately the glider starts moving faster. The glider reaches an annual launch speed of 27 meters per second after accelerating for 11 seconds. So you just pull it like this, and as a result of it, the glider starts moving faster and faster. Assume that the glider moves horizontally until it leaves the ground. Calculate the total distance traveled by the glider before it leaves the ground. What is the distance traveled by the glider? So what's happening? When you say it is now moving, this is my ground. Now when it is moving like this, at some point of time, it gets lifted up like this, right? So when does it get lifted up? What do you put across in physics about lifted up? Which means you have to talk about the normal force, right? Think about it, right? And then based on the normal force, making normal force equal to, I'm not going to tell you this, and then you need to find out what is the total distance, right? The glider and the pilot have a total mass of 492 kgs. Okay, so higher. Determine the During the acceleration, the glider is subject to an average resistive force of 160 Newton. Determine the average tension in the cable as the glider accelerates. So the average resistive force. So as the glider starts moving, there's a resistive force on the glider, and the force is already given to you. Determine the average tension in the cable as the glider accelerates. What could be the tension in the cable? That's what has been asked. You can think of it and try to answer this one here. Right. Let me move on to the next part. The cable is pulled by an electric motor. The motor has an overall efficiency of 23%. Determine the average power input to the motor. What is the output power? You should know based on this, okay, which is already given. 23% is the efficiency. We know that efficiency is equal to output by input. You can use this to get the answer. Then, after takeoff, the cable is released and the unpowered glider moves horizontally at constant speed. Unpowered glider, the moment it starts moving, the cable is cut off and it starts moving. Okay, the wings of the glider provides a lift force. Bernoulli's theorem. So it keeps on going like this, and suddenly it lifts up like this, right? And the diagram shows the force acting on the glider and the direction of motion of the glider. Okay, see, the direction of motion is given, lift force is given, vertical, horizontal, everything is given. What is that you want to do? Draw the forces acting on the glider to complete the free body diagram. Maybe there is something which is missing here. Identify what it is. Okay, dotted line shows the horizontal, vertical lines. Very easy question and very easy to determine. Also, look at it. Then, this is the last question. A girl on a sledge is moving down a slope at a uniform speed. This is the sledge, this is the snow slope, and this is the horizontal region of snow. Draw the free body diagram for the sledge at the position shown on the snow slope. At this point, draw the free body position. You can do it. Okay. So provided you remember which one? The inclined plane problems. Okay. So you can easily do it. After leaving the snow slope, the girl on the sledge moves over a horizontal range of snow. Explain with reference to physical origin of forces why the vertical forces on the girl must be in equilibrium as she moves over the horizontal line. Why should there be an vertical equilibrium? That's what has been asked. Okay. Very easy question once again. Easily you can answer. Think about it. Then, when the sledge is moving on the horizontal region of the snow, the girl bumps off the sledge. The girl has no horizontal velocity after the jump. Okay. Then the velocity of the sledge immediately after the girl jumps off is 4.2 meters per second. The mass of the girl is 55 and the mass of the sledge is 5.5. And the calculated speed of the sledge immediately before the girl jumps from it. Now comes the question of conservation. Which conservation? Think about it. Okay. So using C, O, and M. Okay, I'll tell you the answer itself. COM. What is COM? Conservation of momentum, right? If you're using this, you will be able to get an answer here. The girl chooses to jump so that she lands on loosely packed snow rather than frozen ice. Outline why she chooses to land on the snow. What is the reason behind it? Loosely packed snow and frozen ice. If you are jumping, okay, from a building or maybe from your balcony or from a certain height, which region would you prefer? Is it the granite or the sand from which the granite has been made or the stone has been made? Crushed stones, okay, finely crushed granite particles or just the granite. Which one would you like to do it? You'll always go for the powdered one, right? Right. Now let me move on to the next one. The sledge without the girl on it now travels up a snow slope that makes an angle of 6.5 degrees to the horizontal. At the start of the slope, the speed of the sledge is 4.2. Coefficient of dynamic friction on the sledge is so much. Show that the acceleration of the sledge is minus 2 meters per second square. Now what happens? Now she started from here. She came here down like this. And suddenly, this was the plane. She landed over here. Then she started moving like this. And then once again, she now goes up a snow lodge. So it's like this. Snow slope, she goes up like this over here, up the plane. Okay, the angle of the inclination is given. And then you need to find out what is the acceleration. Acceleration is this. It should be minus 2. Prove it. Easy to prove. Only put the free body diagram. Calculate the distance along the slope at which the sledge stops moving, assume that the coefficient of dynamic friction is constant. So you need to find out the coefficient, distance which along the slope which the sledge stops moving. So initially when it is the horizontal, its speed is much higher. Now the moment it starts moving upwards vertically like this, its speed keeps on lowering down. Why does it lower down? Two reasons. Which one is it? One is friction. The second one is the gravitational pull. Both of them will now try to reduce it. But at a particular state, it will go and stop there. Right? You need to determine what is the distance covered by it. Then the coefficient of static friction between the sledge and the slope is 0.14, outlined with the calculation subsequent motion of the slide. If the coefficient of friction is into the 0.14, then what will happen to the motion of the sledge? That's what has been asked. These are all just kinematic equations. You apply it, you'll get the answer. Okay, I think we have come to the end of this paper, and I hope you have understood the concepts and then try to move on. So if you really like it, do share this video with your friends so it reaches far and near to each and every student. And also subscribe to my channel for more updates. Thank you friends for watching this video until the end. Thank you once again.